Hi everyone. Today in this video, we are going to talk about the basic nature of a magnet and what's the reason behind that basic nature of the magnet, right? When you go to the micro level, the reasons could be different, but we are talking about a macro level. What I mean by that is, say for example, even if you look at an electron, if we have taken an electron who is having a kind of a charge passing, charge itself is a charge, fundamental charge. It behaves like a magnet with the two poles. It has a magnet. It has a magnetic nature, which has a north pole as well as a south pole. One face of it behaves like a north pole, another face of it behaves like a south pole. That's the smallest magnet that we get, and it tells you the story like it's impossible to get an isolated pole. Practically, you always get a dual pole. There will be whenever there's a north pole, there is always a south pole. But how does the magnet behaves like an electron? How does an sorry electron behaves like a magnet? It's a kind of a story we will talk a little later. Now we would like to talk at a macro level, that is at a molecular level. So to explain a magnetic nature, we have a theory called molecular theory. What is it molecular theory tells you is in a given material there will be molecules. Each molecule behaves like a tiny magnet. So the arrow that I'm showing is a north pole for each of the tiny magnet, and the other end is the south pole. So even that small piece, a molecule, behaves like a magnet, and the effective nature of all these molecules together behaves decides the nature of that material itself, right? So there are different kinds of materials, and their magnetic nature is decided basing on how is this molecules are aligned inside. Want me to explain what do you mean by that? So if you consider a material like magnetic material, its molecules are aligned so properly such that the effective molecules together behaves like a very strong magnet. That's like a ferromagnetic material. So this is like a very strong molecular alignment in a proper direction. Where here they are not aligned properly. So though each of the molecule is a magnet, these molecules together are not in a single direction. They are not acting together, and it cannot behave like a strong magnet. So whether someone is a strong magnet or not is simply decided basing on how is these molecules are aligned inside a material. It's not that molecule is not behaving like a magnet. Each tiny molecule is definitely behaving like a magnet, but are they coming together or not is a kind of the story that we are talking about a theory called molecular theory. So the theory is very simple, just to conclude in 2 minutes, that each molecule behaves like a small magnet, and if all these magnets come together, act together, that behaves like a good magnetic material. And that good magnetic material can be magnetized quite easily because the molecules are already aligned. You can just put it in a proper magnetic field, therefore, it becomes a strong magnet. And so that's what you mean by a molecular theories, right? So there are different kinds of magnetic materials like ferro, strong magnetic material, para, weak magnetic material, dia, are very weak, but in the reverse way. It behaves in a reverse way. So, how does they behave? What is their properties? We'll be talking in the course of action. But in a nutshell, what we would like to say is whenever you find a magnet, you will always find a magnet with a north pole and a south pole. Even if you cut the magnet into the middle, it behaves like two different magnets with a north poles and the south poles formed. However small that you get, you still always get two poles. That's called something like a dipole. People, that's why I call it like a dipole. So these two poles are possible because each at the molecular level itself, it is having two poles like a north and a south pole. And even if you go to the micro level, at electron level also, it will have magnetic nature of north pole and south pole. We'll be talking about it a little later in the coming lessons. Thank you for watching.